just going to draw the blue triangle. That is triangle ABD. So it goes like this, and then like this. And then I'm going to draw the peach triangle, which is like this, and like this. Now, this is your A, B, D. If you don't, this is a chapter in which if you don't pay attention, you're not going to understand a single thing. So you have to pay attention. This is your A, B, C. Now in these two triangles, this angle is equal to this angle. Yes, can you see?
Yes, ma'am.
This angle belongs to and this belongs to the peach triangle. So we can say that angle BAD is equal to angle ABC, right? Now, what else is equal? Apart from, see that one side is same, A and AB, the side AB, this side is equal to this side, obviously, because AB is equal to AB. Right over here, you write over here, common side. These two triangles have AB as common. Then what else is equal? Given in the question, it is given in the figure. What else is equal? AD is equal to BC. Can you see it or not? It's given in the question. AD is equal to BC. AD side is equal to this side, BC. And this AB is already equal to AB. So AD is equal to BC. Now, can you tell me which criteria will be used here? Which congruence rule will be used here? They will be congruent, but by which congruence rule? What can you see? You can see that side, angle, side. There's a side, there's another side. And that angle happens to be between those two sides. So this is, they are congruent by SAS rule. By SA, and over here you have to write given. Over here you have to write given. Otherwise, your marks may be deducted, okay? By SAS rule, which triangle is congruent to which triangle? Triangle ABD is congruent to triangle BAC. Why is it like that? Why can't we just write ABC? Because when we say ABD, this triangle ABD is congruent to BAC, that means AB is equal to BA. We should write over here BA. Then it also means B or angle BAD. See, because you can't say that triangle ABD is congruent to triangle ABC. You cannot say this. This is wrong. Why? Because when you say ABD, so ABD, so ABD and ABC. That means BD, if you write ABD and ABC, BD becomes equal to BC. But in this case, it's not like that. BD is not equal to BC. What is equal to BC? AD is equal to BC. Okay, that is why you cannot write ABD is congruent to ABC, because in that, if you write it like that, then that means you are writing BD is equal to BC, but that is not the case. So I hope you have understood why we are not supposed to write it like that. Now, the next part of the question, you have to prove that BD is equal to AC, which means this side is equal to this side. Well, obviously, if these two triangles are congruent, then they are going to be all the parts of the triangles will be equal. Hence, by or you can write hence BD is equal to AC, since since corresponding parts of congruent triangles are equal. In short, we write this corresponding parts of congruent triangles. We write it as CPCT. Okay, CPCT. So in short, you can write by CPCT. You can write it like that, but it's better if you write it in the full form itself. Corresponding parts of congruent triangles are equal. Therefore, BD is equal to AC. The third one also similarly. Triangle ABD, which is going to be, angle ABD, which is going to be this angle, is going to be equal to angle BAC, which is going to be this angle. Okay. So similarly, angle ABD is equal to angle BAC, since CPCT corresponding parts of congruent triangles excuse me, are equal. So please write this. Done?
Yeah.
Shall we move forward? Shall we move forward? Yes or no?
Yes, ma'am.
Okay, thank you. Let's come to the third question. Now, you all have to tell me how you're going to do this, okay? So they are telling you that AD and BC are equal perpendiculars to a line segment AB. So first of all, we have a line segment AB, and they have some perpendiculars. Perpendicular means line segment which are 90 degrees to that line. Okay. So what are the perpendiculars? AD and BC. They are telling you that they are equal perpendiculars, meaning that AD is equal to BC. So that CD bisects AB. So what is given to you? These things are given. You have to show that this is O. You have to show that CD bisects AD. What is the meaning of bisects? Can someone tell me? Yes. What is the meaning of bisect? What is the meaning of bisect? Bisect means to cut something into two equal halves, to divide something into two equal halves. So when they are saying show that CD bisects AB, that means CD is what? This. They are saying so show that CD, which is the peach colored line, bisects AB. That means you have to show that AO is equal to BO. Okay. That means you have to show that AO is equal to BO. You have to show that CD bisects AB. Okay. So now we have two triangles. We have two triangles. Triangle AOD. This is one triangle. And we have triangle BOC. This is another triangle. In this, we have already been given that this side is equal to this side. So one side is given in triangle AOD and triangle. Please keep writing it simultaneously. And triangle BOC. In triangle AOD, you can see that AD is equal to BC, right? AD is equal to BC. That is given. Then angle DAO is equal to angle CBO. 9 degrees given. This is also given to us in the question. One thing is left now. Either we find some other angle or we find some other side. What can we do? See, over here, this angle and this angle are going to be what? Vertically opposite angles, right? And we know that vertically opposite angles are equal. So you will write it like this. Angle DOA means this one. Wait a minute. Angle DOA is this one. So angle DOA is equal to angle COB. Why? Why are they equal? Because they are vertically opposite angles, and vertically opposite angles are equal. So now we have two things. We have A which is angle. Then we have one side, another angle, but the problem is this is not ASA rule. ASA rule is what? Angle side angle. This is not ASA rule because ASA rule means that in a triangle, one angle, then a side and then another angle, meaning that this side should be between those two angles. It should be the side that lies between those two angles. So we can see that the side which is equal is not between these two angles. So what do we do here? Can anyone tell me? Fine. See, if these two angles are equal to each other, that means if this angle is equal to this angle and the 90 degrees equal to 90 degrees, then obviously the third angle will be equal, na? Why will it be equal? Because each triangle, it's going to be 90 plus the pink angle, which is angle DOA, plus angle D. It's going to be 180. And similarly, in the green triangle, also 90 plus angle COB, which is the pink angle, plus angle is going to be 180, right? Angles are property. Now we know that 90 and 90 are the same, equal. DOA and COB are also same. 180 and 180 are the same. Obviously, angle D and angle C are going to be the same. They're going to be equal. So we can say that this rule here, this is also called AAS rule, okay? Angle and then side. AAS rule, these two triangles are congruent. Triangle AOB is congruent to triangle BOC. Any doubts still here, anyone? Then are you there?
Yes, ma'am.
Any doubt?
No, ma'am.
Have you understood anything? Hmm?
Uh, I can't hear you.
I'm saying, have you understood everything?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So by AAS rule, they are both congruent. Okay. Now, if they are congruent, therefore, corresponding parts of angles are equal. That implies AO equal O, hence proof. This is what we had to prove, right? We had to prove that AO is equal to BO. Shall we move ahead? Yes. Yes or no? Move ahead, yes or fine, I'm moving ahead. If you haven't written something, then I can't do anything about it. You guys are not responding. Fifth question. So there is an angle over here A. There's a line L which bisects this angle. That means we had an angle over here. The line L divided that angle into two equal halves. Okay. So now we have a perpendicular from here. Doesn't really look like a perpendicular. And we have a perpendicular from this is 90. This is 90. This is point P. This is point Q. This is point B. You have to show that. And one more thing is given to you, that this angle is equal to this angle. Okay. How do we know it is equal? Because L is bisected, right? L is angle bisected A. That means angle EAB, which is this one, is equal to angle QAB, which is this one. So this is given to us to show that triangle APB is congruent to triangle AQB. How do we show it now? You all said you understood it. How do we show it? What all is equal? Come on. Fine. See. Angle AQB, or let's just start with the one. Angle P is equal to angle Q. Then A to A common both the two triangles like this. So first and so this is the first triangle, and then this is the second triangle. So in these two triangles, the side AB is common. So again, by which condition? We have AAS, right? One angle, another angle, and then we have a side. So by AAS rule, triangle APB is congruent to triangle AQB. So the second part of the question then automatically follows. Just BP is equal to BQ. You have to show that, which means BP is this side is equal to BQ. Or in other words, B is equidistant from the arms of angle A. Equidistant from the arms of angle A. So I hope you have understood that, right? So that means, so we can say that corresponding